Hey everyone, this is Nick DiRobertis teaching you financial modeling. Today, we're going to be doing an introduction on forecasting. This is part of our lecture segment on free cash flow estimation and forecasting, which is part of a broader goal in the course of building out the full discounted cash flow valuation of a stock. So we already covered the historical free cash flow part of all this, so go back to the prior videos to see that. And now we're just getting into thinking about, well, we need to know about the future free cash flows in order to take the present value and get the value of the company. And so that brings us into this whole area of forecasting. So forecasting uh, is a fairly complicated topic. There is a lot involved. I could really teach an entire course just on forecasting. We're really just going to look at a very high level overview on it in general. And it gets quite complicated once you get into the details. Uh, it's a whole branch of econometrics to work on these time series models used for forecasting. People make a living off of researching these things. Uh, People have full time jobs working on forecasting. So it's definitely a full topic to discuss, but we're just going to kind of, briefly look through it and take the most high level things that we need to know about it just to be able to do our own simple forecasts. So, as we talked about earlier in the introduction on this lecture series, um, we are going to be forecasting either the free cash flows or the financial statement line items. And in order to forecast those, we're going to use time series methods, uh, which are methods of predicting the future from the past. And we're going to use those on one of a few possible targets, either the levels of the item, the growth of the item, or uh, the percentage that this item is of another item, which is already forecasted. So these time series methods is any method which we can use to predict the future from the past. So we'll look at a number of simple models such as the average approach, the recent value approach, linear trend, and compounded annual growth rates. And we'll also get into some more complex models which can be used for more complex time series, such as a quarterly seasonal trend model, and looking at more advanced models as well. And thinking about this levels versus growth versus percentage of. So, what we're talking about there is levels means you're forecasting the value itself. So, sales was a million and then it's 1.5 million. We might predict using a linear trend that it's going to be 2 million for next year. So we're using that million and that 1.5 million directly in our forecast to generate the forecast of 2 million. So the original values of whatever item are what we are feeding into the forecast model. Then looking at the growth means that we first calculate the growth rates on the item. So say sale grew 10%, then it grew 8%, and we're feeding those growth rates into the forecast model. So we might predict, again, based off a linear trend, that the next year's growth is going to be 6%. And then we apply that 6% to the prior sales level value in order to get our forecasted sales. And the last target that we're talking about is the percentage of another item. So that means you have some other item which is already forecasted. So say that we already have sales forecasted, and now we're trying to forecast the cost of goods sold. Well, we could say that, historically, cost of goods sold has been about 60% of sales. And so now let's forecast the percentage of sales, which cost of goods as a percentage of sales, rather than the level or growth of cost of goods sold. So then we forecast that it will also be 60% in the future. and then we just multiply that 60% by the forecasted sales to get our estimate of the cost of goods sold. And with all of these different forecast targets, with any time series method that you're going to use, you can still adjust the forecast afterwards. You can say, well, here's kind of the baseline from the model, but because of this new project that the company is going to start, or this additional risk factor which has become more of an issue lately, or whatever your analysis of the company's operations is, you can incorporate that into your projections and say, no, I actually need to adjust some of these periods because of this additional information I have, which is not reflected in the historical financials. And you can also use this kind of qualitative information to actually pick which forecast method and target you're going to use. So looking a little more at what these time series methods are, again, we are trying to predict the future using past information. And there are a lot of possible models that we can use. But the defining characteristics of all of them is that they're using something about the past in order to predict the future. And depending on the model, it's using different characteristics of the past. So it might be the trend, it might be the growth, it might be historical deviations from the baseline forecasts. Can adjust the forecast as well. So there's a lot of different models that we can use there. Some of the simplest ones that you can use, and we'll look at calculating these in a future video. Very simple models, we can just take an average of all the historical and say, well, it's going to be at that average going forward. Or we can take whatever was the most recent value and just say, well, that's our best estimate. What it is now is our best estimate of what it's going to be going forward. And those are fitting in a number of forecasts. It just depends on what you're forecasting. If it's something which tends to be very stable, then these can be good models. But most of the time, probably there is going to be some kind of trend or growth in the historical values. So it's trending up or down, or exponentially growing up or down, and we want to continue that trend or growth into the future. So we'll look at models for both of those. And then there's a whole array of more advanced time series models. And this is where a lot of that research that I mentioned is around. And so there are a few different general categories of how these models are different. One is autoregressive terms, so that means that you're directly using the recent values in the equation to predict the future. Or moving average means that you're taking the historical, you're taking the forecast for the historical and the historical values, calculating what was the forecast error, how much were you off in those forecasts, and those errors actually help you predict what the future is going to be. Or conditional heteroscedasticity, which is a fancy way to say that the variance of the underlying data changes over time. So if your line item is very stays about the same, and then it's changing a lot, and it switches between that, then you should consider one of these kinds of models. And so this is where we get into kind of the alphabet soup of models. They tend to be just named with these different combinations of letters: AR, MA, ARMA, ARCH, GARCH, GAM. Like there's so many of these types of models, which are really going to be specialized for different purposes. So then you might say, well, we have these 4 simple models, we have a bunch of more complicated models. How do I go and pick which model I'm going to use? So there's a number of factors that go into it. And thinking about just the historical data, the how much data you have is important, as well as how frequent it is. And whether there are any historical patterns in the data is going to be the biggest uh, contributor to the decision of which model to use. So if the data is basically constant historically, then the average or recent value approach should be a fine approach. And it just comes down to your judgment call of whether you think that there's going to be some kind of mean reversion, and so the average would be more appropriate, or if it's just going to stay where it's at, and then the recent value approach would be the best choice there. But if there's kind of a trend up in the data or a trend down in the data, whether that's more straight or it's more exponential, then you're going to want to consider using a trend or growth model. So if it's a straighter line, linear growth or decline, you want to use the trend model. And if it's more of an exponential growth or decline, then you want to use the growth model. And if there are some kind of repeating patterns in the data, like maybe it spikes up within every year, maybe you have quarterly data and every second quarter the sales spike up. These are cases where you're definitely going to need to use a more advanced model. Any of these for the average, recent value, trend, and growth are not going to be able to capture these kinds of repeating patterns in the data. That's where you definitely need to go to a more complex forecasting model. But there's a lot of decisions there to be made in terms of what model you're going to use. But what is nice about forecasting is that regardless of what model you choose, you go through the same process to do the forecast itself. You just kind of switch out this model portion in the middle. So if you understand the general process and you can learn the general process with simple models, then it's easy to go and expand on that later, learn the more complex models, and just kind of plug them into this existing framework. So the general process to forecasting is first you want to look at the historical data. Plot is usually a very good way to do this. And if you just have a few numbers, you don't necessarily have to plot them. You can just look at the numbers, but as soon as you have more than a few data points, it makes sense to plot it, visually see it. And what you're trying to do is get an understanding of that data, so that you can ultimately make a choice on what time series model you're going to use. So you want to look for patterns in the historical data, whether it's a repeating pattern and you need a more complex model, or whether it's a trend or a growth rate and you want to use one of those models, or if it's basically flat and you want to use the average or recent value model. And you also want to consider any kind of qualitative knowledge that you have about it. If it says in the company's 10K that they're not going to be purchasing any new fixed assets over the next couple of years, then it doesn't make sense to use a trend if the historical data has been trending upwards. Well, you already know that the company is not going to keep continuing on that path. So in that case, maybe the recent value approach is going to be better. And then the next step is then to fit that time series model. And you'll have to make a choice there on whether you're fitting it on the levels, the growth, or the percentage of this item of another item. But regardless of which you choose, you're just fitting this model. And then you're going to use the fitted model to predict the future. So you'll have some coefficients fitted from the historical data, and then you use those coefficients to then predict the future data. And then you have your forecast, you've predicted the future, and the last step is just to examine the forecast to make sure that you got kind of what expected and that it makes sense. So a plot is definitely the best way to do this. You can look at a plot of both the historical and going into the forecasted, and that lets you visually see, well, does this forecast seem to kind of continue the patterns which I saw in the past? Uh, then I know that the forecast has worked correctly. Unless, of course, you've used your qualitative knowledge to adjust the forecast, and then you're making sure that it is in line with your expectations of the company for the future. So we have to choose the time series model, trend, recent value, growth, etc. But we also have to choose what to forecast, the levels, the growth, or percentage of another item. And there's a little bit different of a process of what you do depending on what you're forecasting. When you forecast the levels, then you just forecast it and you're done. The results from your forecasts are the results that you need, and so you're done. And forecasting the levels makes sense when you have these more complex models, which are really able to take in a lot of features of the data in order to do the forecast. And it makes sense for things which are growing more slowly or on a linear trend. But if it's an exponential trend, you might consider using the growth rates instead. So when you want to forecast using the growth rates, what you do is you first calculate the historical growth rates through the percentage change, and then you run the forecast with the growth numbers instead of the original numbers, and that will allow you to predict the future growth. And then you take the most recent level and you do multiply it by 1 plus next period's growth rate, and keep doing that with each future growth rate to get the level forecasted into the future. And then we have this percentage of item approach, where I think in deciding whether to use that, you should think about the whatever you're forecasting, and how it relates to other things which you forecasted. So having a knowledge of what each financial statement line item means and how it fits in the context of a company's operations is how you can guide these decisions. Uh, Kind of the most classic example for doing this is forecasting cost of goods sold. Cost of goods sold is almost always forecasted as a percentage of revenue, because as you sell additional products, you also have to increase the cost of producing those products. Basically, it's the variable cost. Each additional unit that you sell, you have to pay for the materials which you use to create that product. And so the cost of goods scales with these sales. And so it makes the most sense to just tie these two things together. Um, and then you really just focus on getting the sales forecast correct. And then cost of goods sold just becomes a percentage of that. But you do still have to forecast the percentages themselves. Most commonly, people just use the recent value or historical average approaches, but again, you would want to just go through the same kind of evaluation of the historical data to determine which method to use. But you calculate the historical percentage, so you divide, say, cost of goods by sales in the historical periods. That will get you the historical percentage. Then you feed that into the forecast. You'll get, as a result, the future percentage of this item, of the other item. Cost of goods sold as a percentage of sales. and then you just multiply that by your forecast of the sales or whatever the other item is in order to get the forecasted levels for this item. So yeah, I had that same example here. Cost of goods sold is a percentage of sales. So maybe, maybe the historical periods were like 38%, 42%, 41%. And so you say, well, it's just kind of going up and down. The historical average approach makes sense for the forecast. So the average is 40%. So we're going to use 40% going forward. And then you already have a separate forecast of the sales. So then you just multiply these two things together, the forecasted sales with this 40% in order to get the forecasted cost of goods sold. So that's an overview on everything that we're going to be doing in forecasting in this course. We're going to come back next time to look at the simple forecasting models. So thanks for listening and see you next time.